And with a bit of luck, you should see the first slide now.
Deltaris.
Yeah, well, that's right. Yeah, I was indeed asked to give a bit of an introduction to multi-use of offshore space. And yeah, I'm living in the Netherlands, so most of my experience is also from the North Sea. And I think because the North Sea is such a busy area, that's where most of the experience is at the moment. So first of all, what is multi-use? That is basically the intentional and joint use of resources, and that can be physical space, it can be platforms, it can be logistics, by two or more users. And there are several benefits attached to that. First of all, if you co-locate different types of things, then you use less ocean space. Don't know how important that is at the moment within the Black Sea. In the North Sea, it's going to be extremely important because space is really at the premium there. You can also derive synergies and added values and economic benefits because you can share facilities. You can sort of enable certain uses to happen at all. For instance, for a single wind farm, for instance, it might not be that useful, or there might not be enough capital to have sort of offshore rescue facilities. But if you have several aquaculture farms and maybe some offshore solar farms, then suddenly having that offshore space, having, for instance, rescue facilities there, might be very beneficial. Some types of co-use might also reduce the environmental impact by merging this with other activities. And it will hopefully, in most cases, also provide additional socioeconomic benefits to a coastal region. The multi-use concept, so that can be a lot of different types of activities. Like I said, it reduces the demand for space. There's environmental benefits, socioeconomic synergies, and efficiency and cost reduction. And that's really the driver for looking into multi-use. Now, there is actually already a lot of experience, and there have been a lot of research projects that looked at different aspects. Not all of these were geared towards, for instance, offshore wind and other uses. For instance, the Impact project is a project on integrated multi-trophic aquaculture. So that's combining different types of aquaculture so one can benefit from the rest products of the other one. But there are two projects that specifically have looked at multi-use. Mermaid is an older project that's finished a couple of years ago, and United is a project that started last year. And these two are really geared towards looking at technological and organizational requirements of co-use. So most of the types of multi-use, they can be geared towards other forms of marine energy, so offshore solar, wave energy, and tidal energy. Food production is an important one, particularly aquaculture, so seaweed, shellfish, lobster, fish, and certain types of fishing. Not all types of fishing are really suitable to be carried out in offshore wind farms, particularly those types of fishing using bottom trawling, where you drag a net through the seabed. That can be far too risky, but other types, such as working with lines or with creels, they can be combined with offshore wind farms. Another type of multi-use that's not really here, you can see as an activity or is making use of the fact that within wind farms there isn't really any bottom trawling and no significant disturbance of the seabed, is looking at nature development. In the North Sea in the 1800s, the picture you see in the middle is a very old map from 1883. And that indicates the brown areas are areas that used to be covered with the European flat oyster. It's a very commercially interesting species. It's also, in terms of nature, it's a keystone species. but that species is now completely extinct from the North Sea, and there are currently also under the Marine Strategy Framework Directive, there are efforts to try and get this one back. But because fishing, particularly bottom trawling, is one of the main threats for this species, they're at the moment looking at wind farms, particularly wind farms that are in suitable areas, to bring the species back, because these areas cannot be trawled. And other uses of wind farms is, well, the North Sea is generally, most of the areas in the North Sea are sandy. The infrastructure for offshore wind generally also includes a stony protection layer around the turbines. That's to prevent scour. And this is generally hard substrate. And hard substrate has got different species on it. So this hard substrate is also seen as a possibility to enhance biodiversity. And at the moment in the Netherlands, nature inclusive design, as it's called, so adding even some extra elements that don't do anything for the offshore wind infrastructure, but might provide extra habitat for fish or for other creatures that attach to this hard substrate, they're becoming mandatory. One thing to bear in mind for any type of offshore activity is that each location has got its own challenges and its own characteristics. So the Mermaid project that focused on 3 different sites, a Baltic site, a North Sea site, an Atlantic and a Mediterranean site. So unfortunately not a Black Sea one. The Baltic is really a kind of estuarine area that has got a lot of freshwater influx. And that has an impact, of course, on both the water quality plus what you can grow there in terms of aquaculture. The North Sea, that is a very active morphology site. And what I mean with that is particularly the southern North Sea. If you look at the seabed, it's sand, but the sand is relatively loose. And because it's a very dynamic area with a lot of waves and a lot of currents, that sand tries to, moves through the system. So the bottom is very dynamic, and that puts all sorts of restraints on anything you want to do there, on anchoring, on whatever. The Atlantic was treated in Mermaid, and that's really a deep water side offshore. So on one hand, very exposed to waves, etc., but a very deep water site. And the Mediterranean is also relatively deep, but much more sheltered. And all these different characteristics of these different environments, they were looked at in terms of their opportunities and their threats for energy. So in terms of wave energy, wind energy, etc. Synergies for sustainable aquaculture and interactions of platforms with the hydromorphology and the conditions of the seabed, and or transport optimization and of the installation and the operation and decommissioning. My experience, like I said, is predominantly with the North Sea. And I'm going now a bit to the North Sea. Multi-use doesn't only offer a lot of opportunities, but there are clearly also risks associated with multi-use. So one of the things is in the southern North Sea, like I said, the bed is quite dynamic. So there are, in this picture, which is a multi-beam picture, so you see the topography of the seabed, you see ripples here, and these ripples, it looks quite small on this picture, but it's a fairly big wind farm, what you see here. These ripples can be up to 10 meters high, and they move through the wind farm. So even if you bury cables at a depth of 3 meters, there is a good probability that these cables can be become exposed. And clearly, if you're there in that area and you're there working with a boat, say on a seaweed farm or something like that, these exposed cables with 10,000 volts or something, that's a serious risk. The other thing that is a clear risk is that the situation at sea is quite often rough. The bottom picture you see there is a fish farm in relatively calm conditions around Norway, but there is always an opportunity for either equipment to become dislodged and start moving about, or even for ships to get problems with their steering, etc., and to have a collision with one of the turbines. Even if you don't really physically damage or topple a turbine, you really need some serious force to topple a turbine. What you might do, if there's stuff moving about and sort of coming against these turbine monopiles, you might damage the outer coating that protects these turbines from corrosion. And wind farm owners are not particularly keen on that, funnily enough. Other risks that need to be taken into account is that sometimes the turbines can interfere with radar, so that can influence your maneuvering. And also, if you have, say, a solar farm or a shellfish farm in your wind farm, it reduces the space that the wind farm operator has for maintenance. So that is all things that you need to take into account. Furthermore, anything that leaks in your wind farm can, of course, damage the turbine poles, maybe not so much, but certainly can really damage crops. And one thing which may be valid for the Black Sea as well as for the North Sea. In the North Sea, there are a lot of pipes, not so much for the wind farms, but generally for offshore gas installations. And there might be corrosion of pipes due to electromagnetic fields of the infield cables. Now, a lot of these risks we have assessed and investigated in the Netherlands, and there's a big report on that. Unfortunately, this report is in Dutch. If there are people who are really interested in how this risk assessment was done and which particular types of multi-use were assessed, because there was quite a lot of different types of multi-use, I can see if we can make this available, and hopefully some of it through Google Translator, so you might be able to use it. It is very specific for the North Sea, so not everything might be valid for the Black Sea. One of the things that this particular report also investigated is how much space within a wind farm is actually available for multi-use. And that's a lot less than you would think. If you have a wind farm, which is say 400 square kilometers, it doesn't mean that there's 400 square kilometers available for aquaculture or whatever else you want. The wind farm itself has got quite a lot of space that it needs. There are transformer stations, there are around the turbines, there are maintenance zones, there are safety zones around the infield cables and around subsea pipes, etc., etc. So under the current directions in the North Sea, the cable safety and maintenance zones are 250 meters, and that has a big impact on the amount of space you have. So the green space that you see in the picture on the left hand, that's actually what's available for other types of use. If you define these maintenance zones or safety zones differently, say if you reduce that to 50 meters, suddenly your amount of space that you have available is a lot more. But for the North Sea, that would mean changing regulations and maybe also compromising safety. These days also, all the new wind farms will have passage of smaller ships plus shipping lanes for larger ships. And we found in our analysis that for most of the designated areas for wind farms, the realistically available space for multi-use is about 25% of the wind farm surface area. So if you have a wind farm of say 400 square kilometers, there's only about 100 square kilometers that you can actually use for other activities. One thing to bear in mind, particularly for aquaculture, which restricts this even further, is that seaweed and mussels, or on the right-hand side, you see a mussel seed capture device. They tend to be cultivated on lines, on long horizontal structures. And some of these lines can be hundreds of meters long. It's not allowed to have these structures cross infield cables, even though the infield cables are in the seabed. You cannot cross these with either a seaweed farm or with a mussel farm. That's not allowed. What might be allowed, but would be extremely stupid if you position such structures across the main current, because these structures have a huge amount of drag. If you place these horizontal across the current, they would get, yeah, they would break up. So you have to position them along the main current, and it really depends on the architecture of your infield cables, how much spacing you have for this type of aquaculture. These are two pictures of two wind farms in the southern North Sea. They're fairly close together, and this is the general direction of the tidal current. So you see in the left-hand picture, this one here, I'm not entirely sure if you can see my cursor. Here, the infield cables are positioned more or less across the current. So you only have very small bits that you have for positioning long lines. The right-hand one is a lot better actually, because here you see that most of the infield cables are going more or less parallel to the main current. So here you can position your cables sort of in the length direction of the main current. So that makes also a big difference for your type of co-use that you're planning. So the conclusions is that multi-use for offshore wind farms, it carries opportunities, but it also carries risks. And these risks are, first, very strongly system specific. So not everything I've told here may be relevant for you. But they're also very strongly society specific. In the Netherlands, and actually also in Belgium, there is currently a major drive from a number of industries plus the government to develop, for instance, offshore cultivation of seaweed. They think there is a big market for it, and there are chemical companies that use seaweed for all sorts of products, human food and others. But if you're not in an area where there is a market for that type of co-use, then there's not really much point in developing that. So it depends on the environment, but also on the social environment, what you can and what is sensible to do. What is very important to think, to realize, is that both offshore wind farms, as well as, for instance, aquaculture, can have effects on the environment that reach far beyond the limits of the farms. We are now starting to run some model exercises, or basically hypothetical scenarios of offshore wind farms, and in certain areas in the North Sea, these can have either a boost of the growth of microalgae, so the base of the food web, and in other areas, the effects can be very negative. Similar with aquaculture, if you cultivate in the wind farm, which is located over there, if you start cultivating their seaweed on a large scale, the footprint on nutrients and on the growth of algae can reach over 20,000 square kilometers, even though your seaweed farm is only 87 square kilometers. And these things we're only just starting to understand. So the wind farms may have actually a profitable effect on the opportunities for seaweed cultivation. In some areas, actually they boost the growth of algae, so they will also boost the growth of, say, seaweed. In other areas, they might be a lot less good for your seaweed. Also, the wind farms themselves, they will reduce the wind stress within the farm, and that can help seaweed farms or mussel farms being less vulnerable to waves. So we're only starting to understand all these processes, and also starting to develop tools to investigate this. So that was basically what I was going to say. I hope I didn't take too long. And yeah, any questions are welcome, I think, after this session.